Hi guys, welcome to the section 2 of learning recursion using the recursion creator tool. I hope you guys have actually went down to the previous video and saw all the content which was there. It will actually help you to know what actually is coming up in the next phase and then in the next section. So if you haven't watched the previous section, highly recommended, just go and watch the previous section. Okay, so we are here we'll be learning what recursion is. I hope you guys know a bit about recursion. If not, don't worry, we'll be learning recursion from scratch. We'll be also solving a mathematical problem and then also we'll be seeing the code snippet to actually have a better understanding. So you guys will have a lot of fun. So let's start with recursion. Okay, so what is recursion? If you don't understand recursion and you don't know anything about recursion, just read this sentence. If it is when a function calls itself, that is recursion. Even you can actually read this first sentence itself. If you don't understand recursion, just read this sentence again. If you don't understand recursion, then read this sentence again. If you don't understand recursion, just read this sentence again. That's what recursion is from its core. It just what it does is it just calls the function again. uh it's like I have a few examples, like examples per se. I'll solve one question in front of you to actually explain you what recursion is. We'll be solving a factorial question. If you have done some a bit of programming or a bit of coding, so in your first semester, you would have gone through the Python course, maybe first semester, second semester, and you would have solved that traditional question on this factorial problem, and you solve this problem using your traditional iteration method or for or while loop method. But here we'll be solving this using recursion, and recursion at its core uses the concept of mathematical induction. I know most of us have, like have taken that subject in our high school very lightly, because it was like it's just like a normal or another subject, like a discrete math subject, which like just we just read it up just before the exams and all, we just go, and it was like pretty straightforward when it comes to that. But the concepts of mathematical induction is used inside of this recursion, the recursion we are actually learning right now. It's like a recursion on a very basic level. We just assume something is true, and then we just assume that, and then we solve the problem, and then we prove that our assumption was true. This is what mathematical induction is, and recursion at its very core of mathematical statements and the mathematical definition of it, it's very similar. I know I've said a lot of complex stuff. Let me just like use the pen and just show you some of the stuff that we're gonna actually use. Okay, I have the pen. Okay, here we have a basic definition of recursion. It's like a fact n means factorial of n. N, it could be any number. It could be 1, it could be 2, it could be 3. So factorial of 3 is 3 into 2 into 1, which is 6. Factorial of 4 is 4 into 3 into 2 into 1. That is like factorial 4, 4, 3. Okay, so you actually know it's 24, I guess. Maybe I could be wrong. Sorry, guys. Like I'm just in the middle of. So don't judge me just on the basic multiplication if I can't do. So factorial of n is equals to n into factorial of n minus 1. Complex stuff, but let's break it down. Factorial of n, let's take n is equals to 3. 3, just replace n with 3. So 3 into this factorial, again I'm not writing this because I'm actually using my trackpad, so it's like very difficult to write for me. So factorial of 3 minus 1. Okay, sounds cool. So let's see what happens when we actually run this thing. Let's run it. Let's dry run it. This is what dry run means. Dry run means like you actually take your copy or your notebook and your pen. Pardon me, guys. I have actually have a bad throat. So you take your rough notebook, any notebook, and you take your pen and you just actually write down everything up, and you just run the code or a mathematical expression on your paper, and see what the result is, and then you replicate the same on the code or your console. Okay, so we have factorial n is n. Here we have used 3 for simpler, like for like quick stuff. So 3 is equals to 3 into factorial of 3 minus 1. 3 minus 1 is 2. So factorial of 3 is equals to 3 into fact of, I'm not writing fact, I'm just writing a dash. 3 minus 1 is 2. Okay, but now here the magic of recursion comes in. Listen to me carefully. I know it's very complicated. I've said a lot of stuff. I've said a lot of things and all, but listen to me here carefully. Now this factorial of 3, now which what we have is factorial 2. Now if you clearly see, we have factorial 3 here and we have a factorial 2 here. This is factorial 3 and factorial 2. Can you see one thing? This factorial is calling the factorial this insider factorial function is calling this outside function again, but with this time a different value. Can you see? Earlier it called it for 3, now it's calling it for 2. Like earlier it was like factorial 3, now it's for like factorial 2. So what we'll do is we'll run this function again for factorial 2, and what will happen is it will do factorial n minus 1, which is 2 minus 1, which is going to be 1. So it's going to run again for factorial 1, and then we'll do it again for 1, and 1 minus 1 is 0, and we know the factorial of 0 is 1. So that's how recursion works. And so let's do it again. So here it called here fact of 3 minus 2 is 1. 3 minus 1 is equals to 2. So we'll write here. Now n is 2. So we'll write 2 into factorial of 2 minus 1. So factorial of 2 minus 1 is going to be 1. So now see, again we got factorial of 1, and here we have factorial of 2. So we'll call again the function for factorial 1. Factorial 1 into, I should have left more space in the between, I should have taken it, but just bear with me. Factorial 1 minus 1 is 0. Alright, so I'll do it here. Oh, straight line, see. So factorial of 0, here we hit our base case for 0. In recursion, I'm telling you 3 steps to do recursion. It's going to be the base case, the work, and the recursive call. Base case, the work the recursion is doing, and the base call. The base case here we are taking here is when this factorial of 0 is equals to 1 is our base case. Whenever we hit our base case, we come out of recursion. This is the base case. If we are not coming out of recursion, the recursion is going to be like an endless stuff, like an endless for your kind, like for your visualizations, like an endless loop which is always running, it's never ending. So we need a terminating statement, we need a base case which ends the recursion, and that base case is 0 here, 0. And it is like I think I don't have to do the mathematical stuff to actually prove you why factorial of 0 is equals to 1. You can actually go to YouTube or some stuff like that and online search it for it, but factorial of 0 is 1, which is universally true. You have done it in permutations and combinations as well. So factorial of 0 is 1, and we hit our base case here, and here we come out of the recursion part. It's like we came out of the recursion. So that is how you do it, and the answer of this is 3 into 2 into 1, this stuff, which will give us the answer as 6, and factorial of 3 is 6. So that's what recursion is. Let me just erase all of this stuff. I know guys, it's like a bit complicated, and this is one of the major reasons why we don't want to teach you recursion like this, or in the traditional way which you'll see on YouTube or any other courses, or even in your college stuff, like the traditional way of the academia. We don't want to like actually teach you recursion like this. So let's go to the next slide. Okay, let me just bring it. Can I bring it here? Okay, this is the code snippet. It's like in Python. You can actually like do it in any programming language for like of your choice. Here the similar factorial function, we are defining the function factorial function n if n is equals to 1, or it could be 0 as well, like your choice. Factorial 1 is 1, factorial 0 is 0, so your choice, you can put anything. So return n if factorial 0 is equals to 0, it's like return 0, factorial 1 is equals to 1, so return 1. Else what you need to do, return n into factorial of n minus 1. See, again this function fact here and this fact are the same, but what is happening is we are just having n minus 1, and here we are having n. So it's what it will do is it will just this stuff will call this function again until this base case is hit. You can give 1000 here, and it will run for 999 times. And then when it comes to 1000 part, when when 2 minus 1 is equals to, it's going to be 1, because like 1000 minus 1 is going to be 999 minus 1 is 998. It will go till 2 minus 1 is equals to 1. The moment it will add 1, it will come out of the loop. So this is what it's going to happen in recursion. I know a lot of complicated stuff. I myself, when I was doing recursion, I was learning recursion, I had a very hard time learning it. So we are doing, like try learning it in a better way. and you will actually see how to learn the recursion in a better way in the upcoming sections. So like watch every section and all. Let me just select the curved mouse again. Okay, I hope I actually gave you a glimpse about what recursion is and how to do recursion. You can actually you just learn this, and inside of your classroom lectures also you will learn recursion. That is more than enough for your course, and then you can actually do the assignments and the quizzes and everything else that we and the Professor Jaggalingam is going to provide you. Okay, so the base case craze. Okay, I actually have a meme here. This is what recursion actually looks like. This is a recursive meme, and this recursive meme calls itself again, it calls it again, it calls it again and again and again. This is what is happening. Just let me check if like it's recording or not. Yes, it's recording. See here, there is no base case. So what's happening is the image is getting inside of again and again and again and again. You would actually, if you were like, like if you have actually paid a bit amount of attention in your barber shop, the barber shop basically has one mirror in front of you, and there's like one mirror back of you, so that you can actually have a good look about how your hair looks and all that stuff. So if you have actually paid attention to your barber shop and also, you could have seen there, like you could actually you could actually see yourself multiple times. Your image is like getting inside of it again and again and again. So that is recursion, like a live example. Even your Google Meet, whenever you share your screen, and like you can see like a lot of screens getting inside of it again and again and again. So that is what recursion is. So the base case craze, I just wanted to tell you a very simple stuff. Don't make it complicated here. It's like written over there that people, like, you can actually read this. It's just like we have even cited where we have actually took it from. So here the base case is just a thing which helps you to terminate recursion. That's it. That's all. You don't have to make it complicated. That's it. Okay. Fine, guys. I'm not spending much time on this because I don't want to make it complicated. So you guys can actually have like have a more fun in the upcoming next sections. Okay. Iteration or recursion. Iteration means your normal loops, for loop, while loop, do while loop, etc., etc., etc. And recursion is calling the function again through return statement or to any other stuff, through return statement. Okay, so rather than me giving you a tabular comparison of what recursion versus what iteration is, you can actually go and see it on Google and all that stuff. Let's have a story here. I have actually written down the story here for the ones who wanted to actually read it afterwards, and the ones who are not actually going through the lectures. Still, we are so considerate, and also like we actually take care of everyone. So this is the stuff for them. And for the ones who are actually watching the video right now, just listen to me once. Imagine you are going to a carnival or going to a fest and all. So you are there and you have two other friends. The one is recursion, the other one is iteration. Now recursion is one of the friends who is like like your mystical kind of person who likes to like do stuff. Like imagine there's like a big piece of cake. He will, what he'll do is he'll cut the cake in small parts and then he'll eat the cake again and again and again. While iteration, rather than cutting the cake, it will go through, like it will eat a part of cake and then it will start eating it up and it will eat the whole stuff and again. This is like a very stupid kind of stuff that I actually said. Doesn't make much of a sense, but that is what recursion or iteration is. You can actually see solving this part is like just solving the whole thing but smaller. Like recursion, it's like it will solve the whole thing but it will divide its stuff into smaller chunks, and then it will consume it or it will solve the problem. While as iteration will choose one path and it will follow that path and it will complete the stuff. No mystical, nothing like fancy stuff happening in iteration. You are actually given a set of work and a path. It will follow that path and will complete the work. Very reliable, very good stuff. Recursion also did happen. I'm saying like recursion doesn't work, but in recursion something crazy happens. It's like if you gave like a big piece of work to him, to recursion, so what it will do is it will just like crunch it down to two smaller pieces and it will just do the stuff. So this is what recursion versus iteration is. I hope you guys get a very good glimpse. We are having it a bit light. You can go through the slides again for a better understanding. Okay, so here we end our section. I hope you guys really like learned something from it, and do make sure to watch the other sections as well. So that's it from my side. Thank you so much for listening to me. Have a nice day.